We are going to look at Standard 3, which was questions 16 through 19 on the Unit 1 test. The standard is extending and finding values for a table. That means finding the missing spaces or completing a table. So on this first example, and really any table, no matter what you're doing, I strongly suggest starting with the change in y and the change in x. So over here, change in x, I can see that 4 plus 4 is 8, and I can see that 16 plus 4 is 20. It is likely then that 8 plus 4, and whatever this number is plus 4, will be the pattern that continues. So 8 plus 4 gives me 12, and 12 plus 4 gives me 16. I could be pretty confident that that first missing value is 12. Let's take a look at our change in y and see if that helps us predict. 23 minus 3 gives me 20. 20 minus 3 gives me 17. It seems likely, since the change in x was constant and 2 of our y's is constant, that that will hold true. So I would suggest just trying that to see if that works out. So 17 minus 3 is 14. 14 minus 3 is 11. So I would feel with pretty big certainty that because the change in y's held true and came up with that value, that my two missing values for this first example are 12 and 14. We'll look at what happens when we don't have a constant in some of our other examples. I'm going to shift this up to look at example 2 and 3. So again, we'll start by doing the change in x again. And if you look at this table, the x values do look like they're increasing by 1. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. So I think we can be pretty confident that that last point there is 5. And then let's take a look at our change in y. And I always start with the change in y, even though I'm seeing that 4 times 2 is 8. This was a similar example to one that was on the test where there was some doubling going on. And while 4 times 2 is 8, 0 times 2 does not give me 4. So it doesn't hold true. But I always start with doing the change in y and doing adding and subtracting to see if that's constant first. So 0 plus 4 gives me 4. 4 plus 4 gives me 8. So as I'm seeing that this seems constant in my change in y and that my change in x is constant, I'm going to assume that that constant change continues on and that 4 plus 8 is 12 and 12 plus 4 is 16, and that our table would finish like this. Going on to question number 3. From -5 to -4. And again, if you're not very comfortable with negative values, pull out a number line and look at that. As you go from -4 to -5, because you're going towards the right, that is increasing. So it's +1, +1, +1 as you go through the table there. So this is increasing by 1. And if it helps you to visualize, between -3 and -2, -1 is -2. So that's the missing value right there. So that was our change in x. Now we'll look at what our change in y is. Again, we'll start with adding and subtracting. From 3 to 9 is adding 6. And from 81 to 243 is a big jump. 243 minus 81 is 162. So we can see right away that my change in y is not constant. So we need to look at some other patterns. Um, you can look, we don't really have any second differences that we can see. We could kind of hypothesize what those are. But I hope that you'll see that 3 times 3 gives you 9, and 81 times 3 gives you 243. If you don't immediately see if there is a multiplier, you can always divide consecutive um, y values. So for example, you could do 9 divided by 3 and see that that is 3, and then take 243 and divide by 81, and you will see that you also get 3. So that would be an indicator that as I'm going from 3 to 9, that was times 3, and that 81 times 3 gave you 243. That 9 times 3, and it's okay to use your calculator, 9 times 3 is 27, and you can check that out. What's 27 times 3? And that's just putting the previous answer in there. That's 81. So this tells me that there was a common multiplier going through that problem.